Okay, let's try some of these examples here, A, B, and C. And the functions are given graphically over here on the left. So before we talk about the limits of these functions, let's just think about the two functions. So we have the red function here, and that's called f. And we have the blue function here, and that's called g. So when we add two functions, we don't usually talk about adding functions. We usually talk about adding numbers. So of course we might like 3 plus 2. We of course know what that means. It means 5. But what do we mean when we add two functions? I add f plus g. What does that mean? Basically that just means you at each point, so at each x value, so say at this x value, at this x value, let's get x 0, or actually it's equal to 3, but anyway, at this x value, you just add the heights. So whatever this height is, so this height happens to be 0, and whatever this height is, this height happens to be 1. So we'll add 0 plus 1, which is 2, which is up here, and that's going to be the height of the sum of these two functions. So we don't usually talk about this very often, but that's what we mean by that. And then let's say at 2, when x equals 2, so here, when x equals 2, the blue height is 0, and the red height is about 1.5. So the sum is going to be 0 plus 1.5. It's going to be actually equal to 1.5. So this function is going to go from here and somehow go to here. And I don't know if it goes like this, or it goes like this, or it goes straight, or whatever. I don't know what it looks like in between, but somehow it goes from here to here. And that's what we mean by adding these two functions. So once again, just as another example, when x equals negative 2, so the height of the blue one is negative 1. So that's the g. So g of negative 2 is equal to negative 1. And the height of the red one is way up here, actually, which is 2. I also wrote it here. So that's negative 1 plus 2. So we get, not that, we get 1. So the sum is at 1. So that would be here. So I just drew in some dots here to show the particular heights instead of trying to replicate all these curves. So anyway, that's what we mean by adding two functions. So if you want to know the height of the sum, so first of all, what we should reiterate is when you add two functions, you get a new function. So it's going to be a new function, and then you want to know where is it in the plane. And the way that you figure out where it is you take the height of one of the functions plus the height of the other function, and you just add, those are going to be two numbers, you add those together, and that will be the height of the new function. So if we look over here, we can see f. So f is the red function. So you can see it goes up, there's a circle there, it's filled in up here, goes up and goes down. And the other function is g, it's the blue function, and that goes down here, jumps up here, and goes up there. Now in the first problem, we're talking about the sum of f and then a constant times g. In the second problem, we're talking about the product of these two functions. And in the third question, we're talking about their quotient. So this means that we're going to be bumping into some of these rules. For example, we're going to be bumping into the sum. We're also going to be bumping into a constant times a function, the product, and the quotient. So the first one here, A, is the limit. I'm going to leave out the x here. I'm just not going to write that. The f plus 5 times g. So here we can say we have one function here and another function here. So we're going to call that whole thing 5 times g, the other function. So since we're calling it f plus some other function, we can use this property here, f plus another function. So it says that we can write it as the limit of the first plus the limit of the second. What that means here is that we can say that it's equal to the limit of f plus the limit of this other one, 5 times g, like this. Now, before we do this part here, let's use another rule which allows us to just take this 5 out of there. Remember, we had a rule here, rule number 3, which allows us to do that. So rule number 3 allows us to write this piece here as 5 times the limit of g. So I'll just cross that out and say this is the piece there. Okay, so what do we get here? So the limit of f as x approaches -2, now we have to look at -2, which is where? Here's 0, 1, -2. It's here. So what is the limit of f, the red function, as x approaches -2? So before we answer that, let me just ask you, what is f of -2? Not the limit, the actual height at -2. So here's -2, and the actual height is up here, which is what? I guess this is 2. So the actual height at -2 is 2, but that's not what we're asking for here. We're asking for the limit as x gets closer to 2. So what is that? So that is here, which is, I guess, 1. So that is 1. So this piece here is 1. Okay, then we have plus, and then this piece. So it's going to be 5 times this limit. So this limit is the limit of g as x approaches -2. So here's g, the blue one. And there we can see that the limit is going to be, I guess this is -1. So it's -1. And so we can see that the answer is going to be 1 plus 5, which is 6. So this answer is 6. Okay, now let's do B. And I'll just write it like that because I don't want to write the x's each time. So it's the limit of f times g as x approaches 1. So we have another rule up here, the limit of f times g. It says you can write it as the limit of the f times the limit of g. So it says that we're allowed to rewrite this as the limit of f times the limit of g, because otherwise we don't really have any way to answer this question, because we can't really, well, I guess we could actually, I think it's no, we don't really have any way to answer this, but now we do. So what is this limit? So that's the red function as x approaches 1. Here's 1. So that we can see is 2. So this part is going to be 2. And this part, then we want the same thing for g, at the limit as x approaches 1. So now we do the limit, this part here, but here we have a problem, right? Because this limit g does not exist. So because we have this here and this here. So at 1, the limit doesn't exist. So this part does not exist. So the whole thing does not exist. In other words, you can't multiply 2 times something that does not exist and get something. So finally we can say that the limit does not exist. Now, if you wanted to, you could sort of treat this a little bit differently, and that is, you could say, well, we can't do this problem, but we can do the limit as x approaches 1 from the right of g, and then we can also do the limit as x approaches 1 from the left of g, and we could do this as the limit as x approaches 1 from the right, for example. So we could check out, we could break this problem down into doing 2 parts. The limit as x approaches 1 from the right, and then we would do this limit as x approaches 1 from the right times this limit as g approaches 1 from the right. And this limit will exist as we approach g from the right. We're going to get some value. And this will also exist. So we can do these two. We can multiply these two, and we'll get one number. But then when we do the same thing as x goes to from the left side, we can also do both of those, but we're going to get a different result. So the left side and the right side are not equal, so we would basically arrive at the same thing, that it doesn't exist. Now, what I just said depends on the fact that we can use these rules for as x approaches a, which is how they have them all written like that. They're all written as x approaches a. But these rules will also work if we're just doing a one-sided limit. So you could put a plus here, a plus here, a plus here. That would be true. That would be a rule. You could put a plus here, a plus here, a plus here. That would be another rule. So you could do that, and you could also do it for this. So actually, you have 5 rules here, but there's actually two more sets of 5 for approaching a from the right and approaching a from the left. Okay, now we have this last one, C, as x approaches, as x approaches 2. All right, it's plus 2. Okay, as x approaches plus 2, the limit of f over g. So as x approaches g, so we can write this, we can write this as the limit as x approaches 2 of f over the limit as x approaches 2 of g. But we can only use that if the bottom is not 0. But anyway, let's check the top. As x approaches 2, here's 2, I guess. So we get this number. So we don't even know what that height is, but we could estimate it as about 1.5 for the moment. So let's say it's 1.5 approximately, but it's only an estimate. But it doesn't matter because on the bottom, as what happens to g, it's 0. The limit is 0. So we can't use this rule actually, because this rule only applies when when the limit of the bottom is not 0. So we actually can't use this rule. We can't use any of this. So and we'll also say that this limit doesn't exist.